Sean.
Leila.
I'm Daniel. And together, we'll be solving a differential equation together.
This average human male who initially has 200 milliliters of urine stored in his bladder, and this urine is mixed with 12 grams of salt. Now, let's assume that for this human male, the rate in which the urine enters the bladder from the system is 1 milliliter per second, and the salt concentration of this urine is 9 times 10 to the negative 6 grams per milliliter. Suddenly, the man feels the urge to urinate, so he runs to the nearest comfort room. And as he relieves himself, the rate in which the urine exits the bladder is 21 milliliters per second. So our first question is, what is the concentration of salt in his urine at any point in time while he is urinating? Our next question is, how long will it take for his bladder to become empty? And for the last question, if this man does not urinate for the next 5 minutes, what will be the concentration of salt in his urine?
So the general formula is V equals initial volume plus Q in minus Q out times time. So initial volume is 200 plus Q in, which is the rate going in, 1 ml per second, minus Q out, the rate going out, 21 ml per second times T. So V equals 200 minus 20T. So next we're going to do is to apply the solution. Q in, C in equals Q out, C out plus dx over dt. C out is x over v, so we're going to use that later. So subbing in all the values, Q in is 1 times C in, 9 times 10 raised to negative 6 grams per milliliter equals 21 times x over 200 minus 20t plus dx over dt. We can apply the linear equation here. So p of x is equal to negative 21 over 20t minus 200. Summing it to the equation, v equals e raised to integral of p of x dt. v is equal to integral of negative 21 dt over 20t minus 200. Putting the constants out, v is equal to e raised to negative 21 over 20 integral of du over u, with u being 20t minus 200, du equals 20 dt. So v equals to e raised to negative 21 over 20 ln of 20t minus 200 when applying the integration formulas. And apply log rules because e is raised to ln, so it will become 1. So v is equals to 20t minus 200 raised to negative 21 over 200. So applying the formula, x times the v, which is 20t minus 200 raised to negative 21 over 20, is equal to the integral of 9 times 10 raised to negative 6 times 20t minus 200 raised to negative 21 over 20 dt plus c. So negative 21 over 20, we can convert it to negative 1.05 and we can apply the integration formulas.
After we integrate, we'll be able to get an equation.
C should not be unknown. So to get C, we substituted the initial conditions. When x equals 12, t equals 0. So 12 is equal to negative 9 times 10 raised to negative 6 times negative 200 plus negative 200 raised to 1.05 times c. Isolating c, we get c equals negative 0.04. So the final answer is x equals to negative 9 times 10 raised to negative 6 times 20t minus 200 plus negative 0.04 times 20t minus 200 raised to 1.05. In letter B, we are finding t when v equals 0. So to get that, just substitute the value of 0 to v equals vo plus q in minus q out times t. Since in the first place, we got v equals 200 minus 20t, we can just sub the value of 0 to v. So 0 equals 200 minus 20t, t is equal to 10 seconds. We need to find x when q out is equal to 0 at t equals 300 seconds. So to do that, we need to apply the formula q in c in is equal to q out c out plus dx over dt. So q in is 1, c in is 9 times 10 raised to negative 6. So in this situation, q out is 0, so the values that are left in the equation are 9 times 10 raised to negative 6 is equal to dx over dt. Applying the linear formula, x is equal to 9 times 10 raised to negative 6t plus c. So when x is equal to 12, t is equal to 0. So to get that, we just sub in the values and c is equal to 12. Hence, when t is equal to 300, x is equal to 12.0027 grams of salt.